Section 5, Day 2 continues solving radical equations and other radicals other than square roots. So today we're going to talk about cube roots and other equations that are more complex than the ones we did in Day 1 of Section 5. The steps for solving these equations is still the same. We're not going to change anything. We're going to isolate, raise, solve, and check. Just keep in mind that now they're going to have maybe more than one radical, in which case you would isolate the one that looks more complex or more bigger than the other one. So taking a look at number 1, there are two radicals here, but you don't have to decide which one's more complicated because they're both already by themselves. So you can go right into step 2, which is raising. To undo a square root, we're going to square both sides. Squaring the left gives us x plus 2. Squaring the right gives us 2x minus 5. This is a basic solve equation from Algebra 1. You subtract 2x from both sides. You get a negative x plus 2 equals negative 5. Subtract 2 from both sides. Negative x equals negative 7. Divide by negative 1 gives you x equals positive 7. Just like in Day 1, it was really important to check your answers. It's just as important here. If I want to check a 7, I'm putting this 7 back into the original equation. That means the square root of 7 plus 2 should equal the square root of 2 times 7 minus 5. On the left, 7 plus 2 is 9, and the square root of that is 3. That should equal the same as on the right. 2 times 7 is 14, minus 5 is 9, and the square root of that is 3. So it checks. In number 2, I do have two different radicals, and one of them is a little bit more complicated than the other. So I'm going to take a second and move the smaller radical. In order to move that negative root x, I'm going to add it to both sides. When I do, I'm left with the square root of 2x plus 9 on the left and 3 plus the square root of x on the right. Step 1 is done. Isolate the bigger radical. Step 2, square both sides. This part is really important. I'm going to square the left and I'm going to square the right. On the left, squaring a monomial square root cancels everything out, and all I have is 2x plus 9. But on the right, I have 2 copies of 3 plus the square root of x. And that's going to require me to FOIL. Foiling here is a little bit more complicated than if it were just a regular x. So what we have here on the left is a 2x plus 9. On the right, 3 times 3 is 9. 3 times the square root of x is 3 root x. Root x times 3 is another 3 root x. And root x times root x is just x. If I combine like terms, this 3 root x and that 3 root x will give me a 6 root x. So 2x plus 9 equals 9 plus 6 root x plus x. What you have is an equation that involves a radical. So restart the whole process all over again. I'm going to isolate the radical. To do that, I'm going to subtract x from both sides. I'm going to subtract 9 from both sides. So those cancel. These actually cancel as well. I'm left with x equals 6 root x. In Day 1 of Section 5, we would have divided both sides by 6 at this step, but dividing by 6 is going to give me a fraction. And if we can avoid that, that's probably our best bet. So instead of dividing by 6, I'm going to go right into squaring both sides. On the left, I get x squared. On the right, I end up with 36x. Because 6 root x times 6 root x is 6 root x squared, which is just 6x. In any quadratic, get it equal to 0 and see if you can factor. Subtracting 36x from both sides gives me x squared minus 36x equals 0. Factor out an x and solve. I get x equals 0 and 36. So the 0 and 36 need to be checked, so I'm going to do that next. I'm going to check the 0 first. That means I'm putting a 0 right here and right there. So the square root of 2 times 0, I think that was plus 9. Yep. Plus 9 minus the square root of 0 should equal 3. 2 times 0 is 0, plus 9 is 9, and the square root of 9 is 3. The square root of 0 is 0, and it does equal 3. So 0 checks. I'm going to check 36 next. The square root of 2 times 36 plus 9 minus the square root of 36 should equal 3. 2 times 36 is 72, and 72 plus 9 is 81. So what I really have on the left-hand side is the square root of 81, which is 9, minus the square root of 36 is 6, which does equal 3. That one checks as well. So they both work. Neither are extraneous. Number 3, I'm going to isolate the biggest radical by adding a 2 root x to both sides. So I get the square root of 5x plus 1 equals 1 plus 2 root x. I just took this negative 2 root x and moved it over. Step 1 is done. Step 2, square both sides. On the left, I get a 5x plus 1. On the right, I have 2 copies of 1 plus 2 root x. I have to FOIL the left hand or the right hand side. So recopy the 5x plus 1, and now I'm foiling. 1 times 1 is 1. 1 times 2 root x is 2 root x. 2 root x times 1 is another 2 root x. And 2 root x times 2 root x is 4 root x squared, which is 4x. I'm going to combine like terms and move things over. So I'm going to combine this and this. I'm going to subtract 4x. And I'm going to subtract 1. So that this cancels, this cancels, this cancels. What I really have is x, 1x from the 5x minus 4x, equals 4 root x. That's an equation involving a radical, so I'm going to square both sides right away. Square the right, square the left. I get x squared equals 16x. Anytime you have a quadratic and you want to solve, get it equal to 0 and see if you can factor. X squared minus 16x equals 0. Pull out a GCF and solve. I get x equals 0 and 16. I'm going to check those both. Check the 0 first. So the square root of 5 times 0 plus 1 minus 2 times the square root of 0 should equal 1. 5 times 0 is 0, plus 1 is 1, and the square root of that is 1. The square root of 0 is 0, times 2 is still 0, and 1 minus 0 equals 1. That one works. I'm going to check a 16. Five times 16 is 80, plus 1 is 81, and the square root of that is 9. The square root of 16 is 4, times 2 is 8, and 9 minus 8 does equal 1, so they both check. Just in case you didn't see it, that continues over there. Alright, same thing here. You have radicals that are disguised as fractional exponents, so still follow the same steps. I'm going to isolate this radical first by dividing by 3. Gives me x plus 1 to the 1/3 equals 4. The inverse power of 1/3 is 3, so I'm going to cube both sides. On the left, I get x plus 1, and on the right, I get 64. 4 cubed is 64. Subtracting 1 from both sides gives me 63. I need to check it. 3 times 63 plus 1, so the 1/3 should equal 12. 63 plus 1 is 64, and the cube root of 64 is 4. So I have 3 times 4 equals 12, which does check. So the answer is 63. All right, order of which you isolate this one is super important. I'm going to subtract 1 first. Subtracting 1 gives me 3 times the 5th root of x plus 1 cubed equals 24. Dividing by 3 gives me the 5th root of the quantity x plus 1 cubed equals 8. I'm going to take a second and rewrite the left-hand side. This is really x plus 1 to the 3/5 because that'll help me when using the inverse power. That means I'm going to raise both sides to the 5/3 power. It's the reciprocal of the power I already have. On the left, I get x plus 1. On the right, 8 to the 5/3 means I will cube root 8, that's 2, and then raise it to the 5th power, which is 32. If I subtract 1 from both sides, I get x equals 31. I need to check it. 3 times the 5th root of 31 plus 1 cubed plus 1 equals 25. So 31 plus 1 is 32. I'm actually going to 5th root it first and then power it. You end up getting an 8 here. Plus 1 does equal 25, so it does check.